Here's a quick review of naming acids. Acids are covalent compounds that contain no ions because they're covalent compounds, but they produce ions when they react with water. We call this an ionization reaction, and that happens because HCl, for instance, contains a polar covalent bond. Hydrogen's electron is pulled much closer to chlorine in the bond because chlorine is so much closer to an octet, has a greater pull on the shared electrons. When HCl reacts with water, the water breaks the bond apart, and you have a Cl minus, and you have an H which has lost its electron now, so it's H plus 1, which is not very stable on its own, so it combines with the water and forms hydronium. So the acid name, you would expect this to be called hydrogen chloride, but acids have their own naming system, and it all has to do with the anion that's formed. Because we make chloride here, the name for HCl is going to be based on the word chloride. So binary acids are acids where the anion, the negative ion that forms with water, is going to end in IDE. So that might be hydrogen, something that looks like hydrogen chloride, hydrogen fluoride, hydrogen bromide. And this is Cn-1, the polyatomic, so this would be called hydrogen cyanide if you named them like we normally name compounds. But because they're acids, we're going to use this naming system. And so we have this little pattern here. For HCl, we're going to say hydro, because it has the hydrogen in it. And instead of saying chloride, we're going to change the ending to chloric, and then acid. So this part, the chlor came from the chloride that forms in water. Same thing for cyanide. Cyanide ends in IDE, so it follows this pattern. So we're going to take off the IDE, and we're going to name this compound HCN hydro. Cyan, and instead of ID, we're going to put on an IC. And so we name it hydrocyanic acid, and it was this cyan that forms sort of the base of the name. The next two types of names have oxyacid compounds. Oxy so that the acid has oxygen in it. It's not just a binary with two elements. And the name for the acid comes from the polyatomic name. You remember from the polyatomic video, if you have NO2 minus 1, we call that nitrite. If you add one more oxygen, we change the ending to AT, so it's nitrate. SO3 minus 2 is sulfite. If you add one more oxygen, we call that sulfate. So those are the endings that we're going to change to make the acid name. So in these two compounds, the anion for this compound is nitrite with an ITE ending, and on this one it's sulfite. So all we're going to do to name the acid, HNO2, is we're going to change the ending on the nitrite, the anion that forms when it reacts with water. And so all we're going to do is take off the ITE and replace it with an OUS. So HNO2 is called nitrous acid. For sulfite, do the same thing. Take off the ITE. Now we could say sulfus acid, but it sounds a little strange. So that for sulfur, they do put the UR back in, and we're going to call it sulfurous acid. It just sounds a little better than sulfus acid. And so we took the polyatomic ending, ITE, and we replaced it with an OUS. The other type of oxyacids are those that end in an ATE, where the anion or the polyatomic that forms with water ends in ATE. So we just need a different ending. We can't use the OUS. That was for the nitrite. If the acid has nitrate in it, we're going to add an IC ending, and so we call this nitric acid. For sulfate, we're going to change the ATE to an IC, and again, sulfic sounds kind of strange, so they did put the UR back in and make it sulfuric acid. So we changed the ATE on both of these to IC.